This is Chapter 7, Section 3. This is the third video. Now we're going to do some problems that compare all the different variations in application. Okay, let's say the age range of workers at a grocery store is 14 to 61. So that's my range, right? With a mean of 30.9 years of age with a standard deviation of 9 years. And we're going to assume that the age space is normally distributed. Okay, so if you have a sample of 25 workers, what's the probability the mean age of the workers is less than 35? Okay, so normal dot distribution, so less than 35, right? The average is 30.9 years of age with a standard deviation of 9, and the sample size is 25, right? So the mean of the group is less than 35 for 25 people as the group size. All right, about 98% chance that will happen. So that's the probability. Okay. So what if I ask the group is more than 35? That seems like the opposite answer, isn't it? So couldn't I just take this, copy, paste, and do 1 minus this, right? And you notice it's basically, if you go out, it should be close to 1. The problem is if you go out far enough, eventually it's actually going to be 0.999 repeated forever, essentially. Okay, because the general problem is when you do the actual calculus, it doesn't actually include the 35. But that value is so minimal, it doesn't make any difference. So for argument's sake, these add up to 1. But realistically, it's actually, if you add these up, it's 0.9999999 forever, because of the fact it doesn't actually include the 35 when you do the math. Okay, so let's say we do the sample 49 workers. What's the probability the sum of the ages is no less than 1600? So that means we want to be more than 1600, correct? Because if you're no less than, it means you're more than 1600, aren't you? Okay. So normal, equals normal dot distribution, 1600, comma, 30.9 times 49, because the average is 30.9. There's 49 workers in this example, comma, standard deviation of 9, times the square root of 49 for the sample size, okay, comma, true. The problem is this is 1600 or less. We want no less than, which means more than, correct? So we want to do 1 minus. So we get about an 86% chance, essentially. Okay? Although don't convert to percents, keep as a probability. All right, so again, whenever I see the word total or sum, that means you're not looking for the average of the group, you're looking for the total of the group or the sum of the group, which means you need to be multiplying at that case, right? Is it likely the sum of the ages of 49 workers is at most 1595? Okay, well that seems like I could possibly cheat here and copy this one, right? Paste it here and get rid of the 1 minus and change this to 1595. Because at most 1595 means 1595 or less, right? So it's still 49 workers, right? And it's still a sum or total, so we want to multiply those. So these two should be approximately 1, right? Because that's 1600 or more. This is 1500 or less. There's only a difference of 5 in between, isn't there? And if you kind of look, that's almost 1, but there's a gap of 5 in between, essentially. It doesn't quite add up to what you would think. Okay? All right. All right, so asking individual probabilities versus sum or totals of probabilities, essentially. Okay? All right, let's look at the next one. So 95th percentile, 95th percentile. Oh, did I copy and paste the same question twice? No. This is the sample mean. This is the average of the group. And this is the sum of the group, right? So our sample size now will be 65 workers. Okay. So let's do normal dot distribution, right? So we want the 95th percentile. The average age is 30.9. The standard deviation is 9 divided by the square root of 65. So this is asking for, I'm sorry, this should be inverse, not normal. We're asking for the, we're asking to invert the probability back to an actual years of age, essentially. Okay, so essentially what we're saying is the sample average should be what years of age for 65 people, right? So 65 people, what's the 95th percentile? So the average is 30.9, so obviously at the 95th percentile should be above average, correct? So that number of years, which makes sense. So 30.9 was the average, that's above average, and 95% is, 95th percentile is above average. Okay, so I'm going to take this, copy it, paste it, and put years here. So this question is asking for the sum of those people, correct? So I'm going to take this and times it by 65 and times it by root 65. So if I add up all 65 people and my sample is in the 95th percentile, what is that number of years? It's about 2,127 years essentially. Okay? So what this is doing is it's comparing the 95th percentile for the group average and the 95th percentile for the group total. Okay? So if you look at the way I've set up all these questions, it's asking group average versus group total, right? Right? Group average versus group total, right? So we're comparing the different varieties of ways you can ask the question of basically. Okay, let's look at a question here. Let's say the doorway height, we want the doorway height that allows 95% of men to enter the aircraft without bending versus assuming half of 200 passengers are men. What's the one that's going to satisfy 100 men essentially? So a 757 carries 200 passengers, has doors with heights of 72 inches. The population of adult men has an average height of 69 inches with a standard deviation of 2.8. So these sound like very similar questions, but one is asking about if I randomly select a person, right, from the population, what's the probability that 95% of those guesses I make are, going to fit within this door essentially, right? And the other one's asking a sample size of 100 men essentially, right? So let's go to here. So normal dot distribution, inverse 0.95 comma 69 comma 2.8. Let me double check. So that's 69 and 2.8. Yeah, 69 inches and 2.8 inches, the mean standard deviation. Okay, so if I do that, inches. So if I randomly select somebody in the population, the 95th percentile is this, right? So the chances are they're going to fit within the cockpit. However, if I do normal dot inverse 95th comma 69 comma 2.8 divided by the square root of 100, I'm going to get this number of inches. Okay, so that's the individual 95th percentile, that's the group 95th percentile. Interesting. Two different answers, which is expected. Okay, so the individual versus the group. So this is the probability that, no, it's not a probability. Just leave that as. So that's the 95th percentile of X. That's the group 95th percentile. Okay, which one is a more accurate answer? Well, if you're going to load the plane with 100 men every time, so you're asking more of the group average, right? Because at 72 inches, you're fine on random for a random person. But a random group of 100, okay, you're better off. Oh, I'm sorry. That 90, you're not better off here because that person is not going to fit in. But if out of 100 men, what's the chances you're going to get somebody in there? Not very good. You're going to be good. The group average, you're going to be good, right? So they'll actually fit on the plane. So it's two different questions essentially, group versus individual.